count the value, we take that value minus the mean over standard deviation. Okay, then you will find the z-score. So if the value is outside this 3D, in most cases, we consider that value to be the extreme value, or what we call the outside. Okay? Some people, they set it to be 3.5, because as you see, the 3 does not cover 100%, but it's almost. You understand? So some people, they set 3.2, 3.5, and so on. You will get that in different research. But the default, the most common pressure for the outlier is 3D plus minus 3D, below or okay. Now if you calculate the CD of a given value and you find that the value is outside of 3D, it means that value is most likely to be the extreme value or the outright. How do we detect that? Maybe how do we before we see how it's like? And we'll be starting with the motion. So let's for example calculate the z-score, because the z-score is equal, as I said, it is equal to the observation minus the mean minus over the standard deviation, or the mean of the sample minus the mean of the population. If I do that, so okay, so we call it the function of in statistics. We even have tables. The tables we let's say this go to the 3, and then we have, let's say outside. And then after this, what do we compute? How do you calculate the mean? Let's call it M like this. How do you calculate this? Is the mean of who? The mean of Sarah, isn't it? Okay, then how do you calculate the standard deviation? Let's call it S is equal to the standard deviation is equal to SD of of course, we complete that. Now we can create the z-score. We can say the z-score. We take every salary. We take a salary, the given value of the salary minus what? Minus mean. On over standard deviation. Let's see if this works. Functional oh, you mean going to the next? Yes. Yeah. So you're checking if let's place the mean and see it's being conflicted. Let's see.
Let's see if the name is completed, then I can check it as well. Not found. Yeah. And we function sorry. And what do we get?
While you're in function,
Is it different? Oh, yeah. Yeah. Well, becoming a good programmer.
yes, runs.
Eh?
Wait until you run. It runs.
Oh, it's not fun, but why? The function is running, but yeah, you were right. So the function here was a function, not function. So good. Thank you, please. Okay, let me see. If the function is running, then I can bring a new column and call it I'll try because this is a new column I'm computing. Right, I'll try let me call it I'll try and then it will be the Z function, okay, enter and sorry. Okay, and salary is K equals to 3. Okay. Okay. So we can plot this. Maybe we can plot by using. Okay, let me see if that function. Okay. I mean the new data, the new column is 57. If not there, I go to check. You see, Z outlier is there. Okay. And then sort. Here I can sort that. Let's see. Let's see. Sort. Pixel. Not. Outlier, which is done. Z outlier. See. Here. You see. So the highest, I mean, this is not the highest. So we can go back. I can do this data. So by sorting the outlier, I'm going to view again the data to see when it was sorted, what was there. Oh, well. So it's not. Oh. So it has taken only the outlier because I have mentioned that. So what we have to do is so if we go back to see we have the output because we have set the threshold as a 3. Okay, we can go back and see. You see, we have the maximum is 1.7, and the minimum is minus 1.68. That is even within what? That is within what? Yes. So you can't say this is This is the outline. We don't have any outline.
Is M not found?
M not found. We now have a picture M maybe to like this. Okay. So we have this. We have again, let's see. So M is not found. In R and RStudio we have but it should show there is the current one. There is no problem. Or we can even make it a function of x
Why is it
without mentioning the variable. Hmm? Data is no, we can make it the function of x. It's fine without mention. Then we mention after when we are calling the function. Right, zero. X, and then we have the limit of x. And then we do standardization of x. Then we have x minus 0, and we have a given value x minus 1 is the s, and then we have a carry and so on. Because if we run like this function, let's say it runs because it's a function of x. Then what we do is to make this a function of data salary k equal to 3. So we have this one, and then let me call s or x or x. I don't think here s we can find the value because it's embedded into the function. It will be used just for calculating the z score. So then we have this one. Then we have this one. So we have the same 1.7, 1.14, which is not out of x10. Okay. But there is another checking. So we can have like a letter. I will check the salary maybe or total check the salary. Oh, total pay. Then what do we do? So we take this one. Each we minus the mean because as we said, z is equal to observation minus the mean over the standard deviation. Okay, we can take the mean of total pays. And then what will follow? Maybe we can include n over standard deviation of what? Standard deviation of total paid. This is the z square, isn't it? So we take the total paid minus the mean over standard deviation. Okay. And after that, we can put the z square, say the z x is z. Okay. Maybe say we will calculate half this number. Why is it not calculating the z's? So you have z could be data total page minus the mean of data, okay, the page over standard deviation of the total page. I don't think it's the same. I can come here and say, and say, for example, the mean. The mean is the mean of total grade is the isn't it? Of total data. Then we have to take okay, I run this. And then I calculate the standard deviation aside as the standard deviation SD data and the what? And the what? And the total paid. Then I come to this formula, I say it's a total paid minus the, I change this, isn't it? I change minus the mean, I close this, then over standard deviation is it? SD. Did we not calculate this? What is it? Is it small SD? I don't think it's small. This is the category. No, the reason is the formula was wrong, so I decided to calculate them aside. We have the mean, we have the SD, and then what we have each value minus the mean and the over standard deviation. So let's say, for example, we put on histogram. Plot this set score to see how it looks like. Okay, it's large. So it's telling me that I didn't have the stakes here for this part. So come to this here, and then I run again. You see? Yes. Previous semester. Do you have to get what we call results for?
Yeah.
Because because this thing of normal distribution, yes, okay, it requires no need of prerequisites. No, this is the basic. But it requires that we understand the sense of it. Why normal distribution? So the reason they call it normal, because normal, like normal. Sometimes we say normal. What do we mean by normal? It means all the other factors constant. Well, without considering the other factors, or taking aside the other influencing factor. That's why they call it normal. So the normal, what you call normal distribution, is the default distribution of the data. But we also check the other distribution. Is the data which follows the normal theory. It's like, so if we are plotting the salary, it means people who have high salary, people have low salary, the normal. So which means the graph is like what I showed you, which is normal, like symmetric. Yes. But that graph can have what we call skew, can have the deviation depending on what is not now normal, what we can call abnormal. Because there are people who are having highest salary, extreme salary. Now it is not normal. It is beyond being normal, isn't it? Now, in normal distribution, there's what is called Z. Z score, we will use this is the like the scores we mainly use in the data analysis when we want to minimize the magnitude of the numbers. We use Z scores. But what does it mean? The Z score, it's also the distribution of the numbers. I mean, each number has a corresponding Z score because you can take that number minus the mean and over the standard deviation and then you find the result. In normal way, the Z score would be within 3 minus 3 and plus 3 in a normal. You understand? And I come to say that each value has its corresponding Z score. So now what we are doing here is like we are computing the Z score to check. I will get on that. To check if there are abnormal, there is an outlier. Isn't it? So now if we find a Z score which is outside of 3, which is 4 or 5, that element reads it as an outlier. Now, from the example I gave you here, what calculation I'm making, we have detected a Z score, and we found that for salary we have found 1.7 and minus 1. What does it mean? It's not abnormal. It's not. So which means that there is no extreme value on that value. This is what I'm communicating. Yes. Yes, this is just how to calculate the Z. Because I say it is an element, it is a value minus the mean over standard deviation. That's how we calculate the Z. And then we are I show but sense you don't want to do this. We want to push it. We are right. Uko salary zacu distributed. Twabonye nawe byazina ngo ko dushaka muri data ushobora gusanga hari abo zirimo nyinshi cyangwa zitarimo. Kuriya rero iriya variable ya salary nibyo rwose ntabwo harimo izo mfano ibyo byahirya ya nimwe byinshi twese twavuga ya normalite ukurikije niyo mubana twerya ya statistic salary zacu no distribution. But actually, so I'm trying to show you many techniques. You can find one in which is a bit not clear, but there are several. I'm not showing one. Okay? So this Z score is the other one, but you can check using the box plot, using the histogram. It's up to the editor. We can find which one can I use. Okay. So now after we find this, like we said, the outlier, the possible ways is to call back to the field to confirm if that number is correct. The second one is to either remove. You can remove. The third one is to change the analysis because some analysis will be affected by that outlier. I told you outlier in one sense or another, outlier may be worse than a missing. You understand? Yes. Okay.
Question.
Yes.
I was trying to run the histo code of Z, but they're telling me that the X must be numeric.
Yes, depending on what you are setting as X. What are you setting as X? Because this is a function, does not mean you bring salary here. This is a function. Yeah. Now, after the function, you will need to pass the function. You see the function here.
Yeah.
This Z is now the name of the function, the global and random function.
Sure.
Yes. You can check. Now we are still in data cleaning.
the easiest part of the data management. But it is very to a data to be and right. Because we can compare let us look at how now we can deal with inconsistencies.
How do we deal with inconsistencies? Okay. So what do we call inconsistency? Last time I gave you the example. I give you the example. We may have like a province. In the province, we have Kigali. People write it like this. Others, they write it like this. Okay? Others, they write it like here. Gahunda yo kwandika Kigali kuriya yagiye. Iyi yazibizora? Bikuriya yitwa gute? Kigali. Nacha. Naka. Kabgayi byose nibyo washatse kutuvana. Kizera turi ko. Turayubaha nta kibazo. Okay. You see, we have different incomes. Are you following? This is very important because whenever you check levels of a factor, let me give one example here. Okay. So we're checking levels. We check levels of what? Levels of which variable, for example, education or province. Let's check and see. Oh, it's not a bit. How is it being treated? Hey, it's character. Okay, sorry. So let's check. Let's make it vector first of all. Vector. Oh, let me check which one is the effective fact. So we can check the labels. We have factor. Factor, yes. We have salary. No, categories because we created it. So let's see, for example, we have data, we have the progress, we change it into the factor. Change it into a factor. Okay. Let's see whether, okay, let's check it again. So, progress. Oh, okay. Okay, you see now it's a factor of 4 elements. Okay. Now, if we check what we call the levels, it means the what? They attribute the what? Okay, you see the levels, we have east, north, south, and the west. Those are the levels of the province, isn't it? Yes. Now, let's say, for example, so they are writing correctly. So that's the problem. So, except I go to the data set and change. But do you have inconsistencies here? Do you have inconsistencies? But they are writing correctly, isn't it? So, so what we call inconsistencies, as I gave an example. So what we call inconsistencies, it means, for example, east is written as est, like that, okay? Maybe I can check into the data frame, the data. Are you following? Because what I'm going to change, you may ask why, and so, okay? So we have east, for example, let me do it as the EST, like that, isn't it? So I'm changing it to the EST. Maybe I say ST, I change east, and I say also ST, and so on. Okay, you can make a lot of change, there's no problem. So I save this. I go back into the data frame. I go back into the scripts. Do it. Page and the finger. And prepare the page. Oh, still I have to maybe prepare the page. There it is. Maybe prepare the page. Yeah, I'm assigning something to this one. Okay. Now, this one, okay. Now, see, how many levels do I have? The only thing I did is to change into the original data set, isn't it? Because we didn't have the consistencies, and I have to show you how to manage them. Isn't it? Yes. So we have east, and we have this. Can you please? This is very, very important in data cleaning, dealing with inconsistency. You can see here it is east, this is east, this is north, south, east, and west. Okay? So which one is inconsistent? So you can see this is a problem. So we need to make sure that we harmonize, we make this common, that the first one replace this one, replace ST, and so on. Okay? So how do we deal with this inconsistency? But this is one example. So those who do we have people who studied Kobo last time? Kobo, yes, units. Okay, yes. Do you still remember the reduce function? Yes, reduce function. The constraint. Yes, the constraint. Here it comes again. Did you love it or it is complicated? Oh, yeah. You fall in love. Yes. Okay, now checking or repressing or managing the inconsistencies. Managing inconsistencies. Is it okay? Like the South African president, is it the president or the other person who failed to say in the beginning? It's the beginning. He repeated even when you are watching that video, you even forget the real term. Yeah, influence, because you think you are the one who is wrong. In the beginning, he repeated like 5 times. Okay, so how do we manage some inconsistencies? We can use the prepackage. So we can use the prepackage. Let me show you 2 techniques. You will choose one. We can use the prepackage. So you can say, for example, my data. When you assign, you use mutate, because we have seen you can. So we have data, you then control shift on, and then you do what? You mutate. So in mutating, you just say case when. Okay, the province, you use that one only. Okay, a combination of, you can specify. You say, for example, the combination of KGR, the combination of who is the combination of who is T, like that. What else? ST, the combination of who? I think those are the ones, isn't it? Yes, is like that. This one, make it what? Make it east. This is how you say it, and then you say true province. True approximate, true progress. Make this change, that's what it means. Make this changes into progress. Save a new progress, actually. Yeah. So you can do this and see if it works. Let us view what? View data in a province. In province. Oh no, levels. Let me check the levels again. Those levels, they are the one which will tell us whether it has been replaced. Oh, no, what? What do I have to do here? Plug this in, combination of this one, make it fist. And then it's not working. The dimension, that's replacing variable. Okay, then you can have one. Right. Wait, let's go to check why it's doing. Yeah. Oh, I see. So it's making a new data frame, but I want to change the existing data frame. Save. This again. True. Okay. 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 So it's making change that in a new file. So case one, let me see if So it's working with the case when, but it's not being replaced in the other. So what do we put? So no, I without yes, so inconsistency has been inconsistencies. They are changing, but being stored as a new column, which I don't want, but I want to replace the existing with the other variable. Another one. So you see, we have this. And start with this. Doing forward. Here. So we need to add a new function to this. Okay, so if we use the DP function and we say please in the province where we have these factors like east, like st, like whatever, so make them east. So this one will work. But if we code the labels, it will still bring the other one. So because it has been computed, yes. You see, check the data. It has been computed by one stored which is not a very big problem. So we have case when here. So case when is a new like progress without inconsistencies. So we have this. So we have the progress here with some inconsistencies, and we have a new progress here without inconsistencies. Maybe we can rename it progress new or something. Okay. Yeah, I think, yeah. Let's see. Because case when is becoming the new column. Let's see. This one can work. We don't need to So these are a few codes. Imagine if you need to rerun like 1,000 codes. very big increment. Okay. Now let's learn this and see whether this is going to be helpful. Let's view the levels. The levels means we are viewing what? We are viewing if we have if east has changed. This. You see? Actually, for this is oh, you want to mean this is a character. We need to change into the factor to see yes, it's a character. So let's change it into a factor. So then we change as the factor. We have this one, and then we call it. We call the levels. Better of the previous. So now this one is okay. Oops. So which means we need to, for every vector, every string, we need to change, every factor we need to change it into a factor. But let me show you the other second way. Maybe you can know which one. The one that I was saying about the guess function. So what does it do? The guess function, you will not need to specify. You just specify one thing, and then it will make the rest. For example, let's see. We have to install first of all stringer. We have to install one library, install one package. It is called string to be able to use this regex function. Okay. So you see that. Okay, then you call it. And then what you do is the regex function. You just say beta. Okay. Then you have control shift N. Then you do mutate. It's like mixing the degree and the stringer function. Mutate province equal to the string replace. String replace. You see, string replace is one of the functions from stringer package. Okay, and then we say replace, string replace. We have different functions there. String replace or, which means replace matches with the new text. So if something matches with this, replace or. Okay, yes. So replace into the province. So now we are going to specify using the get function what do they match with. Let's say we have wherever there is st, isn't it? Wherever you have to put this in, where is that? This one. Wherever there is st, okay, and then so wherever if it has st, then the lower cases and change into the lower cases put true and change it into is true. And then what you do, change this into is. Let us see if and match. So this so what After here. No, let me put here for now. Yes. Because this one is closing the province. And this one is closing the mutate. I think this is now. Then, but see, because we have replaced, we can't see the change. Let us okay. Let me do it for a new variable. Let me change. That was east. Let me change maybe what? Maybe Kigali. Do we have Kigali there? We don't. Let's say in west they say we s west. So west they say W. There are people who don't write west, they write W, for example. Okay. So we have west here, which is WST, and then we have W. I'm just changing as if this is the real data set they gave us. Yes. Okay. West, things like this. So I come here and I say, so this is like the noisy data set they gave us. So I will have to bring it back because I have to do an import again. Sometimes when you have a lot of codes, you think like you can buy a supercomputer so that you click. But this one is not. Okay. Okay, now let us check before I go to that. Let us check the levels of the province now. The levels of the province. We need this province as the province as the factor. Like this, and then we check the level and see. You see, among the levels, we have what? So we have this east, whatever, we have north, we have W, we have west, we have WS, and so on. Now, what is the hint for west? What's the hint, like the common item for west? Isn't it? So everyone who was trying to write west has mentioned at least W. So now what we have to do, we go to our guest functions. I don't know why this is not here. We get so we say wherever there is that W, please change input. And let us see what is this. Okay, let's check again the levels and see whether at least this one has changed. But why is it changing? Because I don't have to convert it to factor. So we have this one, this. And then we have levels of the progress. Takes, why did it not change? I will have progress equal to okay. Okay, let me briefly see if there's maybe a change that we didn't recognize. So we have to you see north, the east has changed, isn't it? So I got this library. Why? Oops. So it gets, do we have any error here? We can print errors equal to string replace start of it. And the function, the get function, lower cases control, and then proceed this. So why is it select? Straight up west, yeah. So here it is taking what? Do you see the observation? Wherever there is W, it is writing to the, like for example here it was WST. So it's right west. You see that? West ST, West T, West S, West S. So what I have to do, otherwise we can use the other memory without this function. Because I don't know why. Yeah. Let's see if I can. Okay. Let's go for this function and see. I use west and other things. Let's take this. I checklist. Wait, I have to discover the reason we are having. It's for tomorrow. I can't sleep. No, wait, we still have one important